So we're up to chapter 3, which talks about branch connections. I was going to demo PPPoE, but GNS, because I set it up at home, I had a certain IP address. Now, because I'm here and I've got a different one, it spat the dummy. But anyway, so life. Anyway, so talking about branch connections and so what technologies get used. And so we'll talk about remote access connections. We'll talk about PPPoE. We'll also talk about VPNs and tunneling. And I'll demo GRE tunnels. And there's also BGP, or Border Gateway Protocol. Probably mentioned it several times this year. And so we'll actually have a bit of a play with it. Lab's got a set up for it. So remote access connections. So basically, what connections are available, and so of course cable is one, and so of course cable uses coaxial cable that carries radio frequency signals across a network. The cable systems provide high-speed internet access, digital cable television and residential telephone service. It's often called HFC or hybrid fibre coax, so enables networks to do high-speed transmission of data. So what I mean by hybrid fibre coax means that they run fibre from the central office to a point, and then it actually changes over to the coax, which is what the houses connect into directly. So two types of equipment required to send signals upstream and downstream on a cable system. So you need a CMTS or cable modem termination system at the head end of the cable. At the head end of the cable operator, the head end is a router with databases providing internet services to cable subscribers, and then there's a cable modem. And I only just noticed the picture covers up the text, but anyway, and so that's basically the other end of the link. And so basically, they do frequency division multiplexing on cable systems where there's a frequency for each of the channels that they sell, and they also set aside bandwidth for data down and data up. Again, for home users, it's normally a lot more data down than it is up. You normally download more than you upload. And so, yeah, so basically that's how they divide it up. Now, I'm not exactly sure how it works these days with the NBN, because can you actually get cable directly from it, or do you have to subscribe over the internet? I'm not sure. I'm not in a cable area, so I can't really tell you. Anyway, so DSL, and so which of course stands for digital subscriber line, which means you can provide high-speed connections over the already existing copper wires. And so there's two major flavors, but of course there's many subsets of that. And so asymmetric DSL is what normally goes to home broadband users again. And so they set aside more downstream bandwidth than they do upstream. Symmetric is where it's balanced up and downstream, and so that's more suitable for businesses. And so for satisfactory DSL, the local loop length must be 3.39 miles or less, basically. And so they've got a diagram here, and again, there's frequency set aside for POTS, or plain old telephone service. You only need 4K of the bandwidth space for the old telephone service. And so if you're still on a DSL area that hasn't gone to NBN yet, you need to have those splitters, don't you, to get your phone to work. And so that's basically just a filter where it filters one part of the stream to one port and the rest of the stream to the other port. And so, and then of course, then you've got the bandwidth for download, which of course is that larger chunk, and then upload, which is normally the smaller chunk for ADSL at least. Of course, if you have NBN, fibre to the node, like I do, it is actually DSL from the node to my house, just that it's VDSL, which is basically a higher speed one, as opposed to, because the distance covered by the copper is less, you can actually do more speed with it. And so a DSL connection is set up between your customer premises equipment, or your router at home, and or on premises, and a DSLAM, which is your DSL access multiplexer, which of course is inside the exchange or central office. And so key components are a transceiver, usually a modem and a router, which connects the computer to the teleworker to the DSL, and then of course the DSLAM is what's inside the exchange. Advantage of DSL over cable is that DSL is not a shared medium. Each user has their own separate channel back to the exchange, while with the HFC, the coax part, of course, is shared by however many houses are connected to that one piece of coax, and so you're sharing your bandwidth. If you got it to yourself, good luck to you. Most people don't. So, of course, there are wireless options as well, and so there is municipal Wi-Fi about. Don't think a whole lot in Adelaide these days, but anyway, there used to be Adelaide Free in the city, but I'm saying 4 days a week I work in the city and I haven't seen it much recently. And so basically they normally make a mash of access points. At one stage, when before our office moved inside the TAFE building, I actually used to get Adelaide Free reception better than I used to get the TAFE Wi-Fi reception. Because the antenna was right outside my window for Adelaide Free, and I'm not sure where it was for the TAFE Wi-Fi, but it wasn't very close. Of course, other connections are cellular or mobile networks, so your 3G, 4G, 5G coming towers, and so, of course, that's certainly out there, and there's a lot of it, but normally not particularly affordable. And of course, 5G in Adelaide, I think, is pretty thin on the ground. Of course, the other option is satellite, and so used where land-based internet access is not available. And so with that, of course, it's going via a satellite out in space, geosynchronous orbit, and so you can get really good bandwidth, but the downside is there's normally a fair bit of latency because that signal has travelled a fair way, several thousand kilometres. And so WiMAX certainly is an option in Adelaide. I actually used to use it at one stage through Newscope. Of course, they've been bought out by Superloop, if you've heard of them. They sponsored the V8 supercar race. And so they actually do it where there are broadband black spots around Adelaide. They've actually got antennas. And so our local supermarket has the antennas up for WiMAX. So how do we compare broadband solutions? And so basically, there's a whole pile of things you need to compare, so like availability, and then of course any limitations in the technology as well. So cable, of course, as was mentioned earlier, shared by many users during peak data. Your bandwidth is probably going to drop. DSL, basically, if you live right next to Exchange, you probably love DSL. If you don't, you're probably not a big lover of it. So fibre of the home, of course, it is available in some parts of the country, but you had to be one of those exchanges that was done first before they watered down the NBN. Cellular mobile, there is fairly decent coverage, but of course, when they talk about coverage of the population, it's normally 93 or 96% or something like that. That's of where people live. It's not 96% of the country, especially Australia. Wi-Fi mesh, it's not particularly common. And of course, satellite is expensive, and you've got those latency issues. So now last chapter, last week was PPP. So we looked at that, and so it's a WAN link solution that runs over serial cables. And so, of course, some of the advantages of PPP is that it actually has a solution for addressing client computers. And, of course, it has that CHAP authentication that we were talking about as well. Now, Ethernet, Metro Ethernet, of course, is becoming more common. But, of course, there's no authentication process built into Ethernet. And so, basically, what they've done is they've jam the two together and made a solution. And so PPP, of course, can do authentication. And so they've, instead of reinventing the wheel, they've just utilised PPP for its authentication purposes. And so with PPPoE, PPP over Ethernet, it creates a PPP tunnel inside that Ethernet connection. This allows the PPP frames to be sent across the Ethernet cable to the ISP from the customer's router. So to create a PPP tunnel, a dialer interface needs to be configured. And so you just do interface dialer and a number. One is a popular number. And then you actually need to tell, this is the client router, of course. You need to tell the router what host name it is, and so that's basically sent as the username for the connection. And of course the password is its password. And so that will actually be sent through the PPP CHAP negotiations, and that's what will be authenticated. There are some other settings as well, the lab in the chapter does actually show that. And so the physical Ethernet interface is connected to the DSL modem, is enabled, and then you do PPPoE enable, and away you roll. Now, like I said that I was having a little bit of trouble with GNS. It didn't like me moving to a different network. And so the reason I care about that is because PPPoE is not supported on Packet Tracer. And so you either need to use hardware or GNS3, basically. All right, so PPPoE will not work on Packet Tracer. And so getting back to this, so the dialer interface is then linked to that Ethernet interface with the dialer pool number inside the Ethernet configuration. And you also need to decrease the maximum transmission unit by 8 bytes, because the PPP header is another header that needs to go over it, and so you need to trim down the size of the packets so that the Ethernet and the PPP header can fit in the same packet. Okay, once you've got it up and running, how do you verify that it's working? Show IP interface brief will do that. Of course, show interface dialer will also tell you that. Show IP route will also do it. And show PPPoE session also tells you information about any active sessions. So how do we troubleshoot it? So basically, the normal causes for problems are PPP negotiation, authentication processes that cause it problems, or whether you haven't done that MTU command to actually trim the maximum transmission unit by 8 bytes. And so with debug PPP negotiation, you can actually see as it goes through, and I think this looks like it's a successful one. Yes, and so you can see that it's installed a route to that interface. Authentication, of course, is very similar to what we did last week with PPP CHAP, and so again we can see that we sent the username Fred apparently, and we had CHAP success. And so, of course, PPPoE supports an MTU of only 1492 in order for that extra 8-byte PPP header. And so with show running config, you should look to make sure that that command is in there. The IP TCP adjust maximum segment size interface command prevents TCP sessions from being dropped by adjusting it to during the three-way handshake. Now, VPNs. So, of course, a lot of companies these days use a normal internet link on every site, and then they actually set up what's called a virtual private network to link, branch offices with main offices. And so the beauty of that is it will normally save you money. You don't have to pay for a dedicated leased line. And of course, you can have your company traffic and your internet traffic using the same link. And so, of course, the VPN gives you the privacy. Now, no encryption system is perfect, but it's pretty damn good. So basically, a secure implementation of VPN with encryption such as IPsec VPNs is what is usually meant by virtual private networking. To implement VPNs, a VPN gateway is necessary. It could be a router, a firewall, or an ASA, which is just a Cisco firewall. And so the benefits include cost savings. You don't have to, as I said, have dedicated links for these connections, scalability, and so it means you can have multiple VPNs over this one link to the central site. Of course, it's compatible with broadband technology, and VPNs are pretty secure, as long as you set them up right, at least, using more modern technologies. Now, there's more than one type of VPN. And so, of course, what I was talking about earlier were site-to-site VPNs. And so where it's an entire networks are connected to one another. And so in the site-to-site VPN, end hosts send and receive their traffic as per normal. And then that gateway will actually interpret the traffic and say, is that going to head office or whatever it might be? And basically you define interesting traffic. And then that interesting traffic will then be encrypted and sent across to the, of course, the matching router at the head office site or wherever it might be. And so the hosts don't actually have to worry about it. It's the router on your premises that will need to determine whether the traffic is interesting or not. Remote access VPNs. And so that's where you have people who may be traveling salesmen or people who work from home occasionally can securely connect their host computer to your corporate network. And so basically in that case it's normally the host computer that actually has some VPN settings or software installed, and it will connect into your VPN server on your network. And so it allows for dynamically changing information can be enabled and disabled, used to connect individual hosts that must access their company network securely over the internet. VPN client software may need to be installed on the mobile users' end devices. And there's also dynamic multi-point VPNs. And so it's a software solution for building multiple VPNs. And so it uses several technologies. And so basically it creates a next hop resolution protocol, which is a mapping database of public IP addresses for all tunnel spokes. And then you have a multi-point generic routing encapsulation tunnels to support the multiple IPsec tunnels. And then you have the IPsec or IPsec encryption that, of course, secures the data in transit. Now, GRE is generic routing encapsulation. Now, GRE actually does not encrypt data, but it tunnels it. And so it can be a solution for several problems that exist. And so one thing is that with most VPNs, you can't actually send multicast traffic or broadcast traffic over a VPN connection. And so what you might actually need to do is create a GRE tunnel which will allow that, and then you do an IPsec tunnel to move that GRE tunnel. And so that is sort of layering of solutions to get the job done. And so it was developed by Cisco. It manages the transportation of multi-protocol and IP multicast traffic between two or more sites. The tunnel interface supports a header for each of the following. And so encapsulated protocol or passenger protocol, an encapsulation protocol or carrier protocol, which is GRE, and a transport delivery protocol such as IP. So it's defined by IETF standard RFC 2784, so might have been developed by Cisco, but it's standardized now. In the outer IP header, protocol 47 is used, and then the GRE encapsulation uses a protocol type field in the header to support the encapsulation of the other layer 3 protocols. It's stateless. It does not include any strong security mechanisms. The GRE header, together with the tunneling IP header, creates at least 24 bytes of additional overhead for tunneling packets. So how do we create a GRE tunnel? So you need to create a tunnel interface with the command interface tunnel and the number. And so in this case, it's tunnel 0. And then with step 2, you configure an IP address on that tunnel interface. You then specify the tunnel source. Now, in this slide here, it says you give a source IP address, but in Packet Tracer, it wants a source interface. And so S000 or whatever it might be. Then you specify the tunnel destination IP address. So that's on the other end of your link. And so, the other site basically. And then you then can do the tunnel mode. And so now in this example here, you can see that they're also running OSPF through the tunnel, because that's the only network they've defined is the same addressing as the tunnel. And so I suppose that's just a bit of a proof of concept, of course, that OSPF mostly uses multicast traffic to talk to one another. And so you can actually get that through multiple links through this cloud up here from one host to another, and it's as if they're directly connected. So the tunnel source and tunnel destination commands reference the IP addresses of the pre-configured physical interfaces. And so, of course, you need to have the physical interfaces configured as well. I will demo this a bit later. And so how do we verify it? And so you can do show IP interface brief again, or show interface tunnel. Of course, because we're running OSPF over it, you can actually see what neighbours it's formed adjacencies with. Now, how do we troubleshoot it? And so again, you can use some of the same commands. And so basically, there can be issues. Of course, the tunnel destination needs to be reachable by some means or another. So you may well need to have a default route or a static route to tell the router how to get to that destination if it's not the next host, which it probably wouldn't be, because otherwise why would you bother tunneling? And so you've got to make the other interface does have to be, or the other end of the tunnel now does need to be reachable somehow or other. And so that's often your problem. So little typos, of course, can cause that. Now, BGP, Border Gateway Protocol, the E in front means external. You can also run BGP internally as well, but E means external BGP. So, of course, internal gateway protocols used to exchange routing information within a company, or AS, autonomous system, while an exterior gateway protocol is used between different companies. Normally, it's ISPs and large IT companies that will be bothering with this. So, Border Gateway Protocol is the most common version of an exterior gateway protocol. And so every AS is assigned a unique 16 or 32-bit AS number which uniquely identifies it on the internet. So, as I said, there's eBGP or there's iBGP. And so, again, internal means, of course, it's within the AS. E means between ASs. Two routers exchanging BGP routing information known as BGP peers. You actually have to tell it who its peers are going to be as well. It doesn't just form a peer relationship with any old router. So BGP is used when an AS has connections to multiple autonomous systems. This is known as multi-homed. A misconfiguration of a BGP router could have negative effects throughout the internet. So BGP should not be used when one of the following conditions exists. There is a single connection to the internet, or another AS known as single-homed, where there is a limited understanding of BGP. Although it's not recommended, it is recommended only in unusual situations. For the purposes of this course, we're going to have single-homed BGP. But normally, the whole point of BGP is you can become a link in the internet, basically. That's normally the whole point of it. So you start advertising your networks to the rest of the world. That's wonderful. But also other people in the rest of the world are going to start using your links to get traffic from A to B. So, BGP options. 3 common ways of organisation can implement BGP is you can have a default route only, you can have default route and ISP routes, or you can have all internet routes. And so this would include routes to over 550,000 networks. So your routing table starts to get very, very big. So, how do we configure it? Well, router BGP and AS number. And this time, don't fudge the AS number. EIGRP, everyone used 1. I wouldn't use OS number 1 on BGP. Then you need to actually type in a neighbour command, and you need to specify their IP address. You also need to specify their remote AS number. So you need to know that information. So if you're going to join your network to an ISP's network, you need to negotiate with them. All right, what peer address am I going to use? What is your AS number? And so you'll need to know that. Now, the network command, you might think, great, that's familiar, and it is, I suppose. But the difference with BGP and other routing protocols is this is just telling BGP what networks to advertise to the rest of the world. It will not advertise it unless it has a route to it. So that, again, you might have OSPF running within your organisation, and then you only, with BGP, that network command just controls what ones actually go to the rest of the world, because that's all that BGP is talking to the world. And so you wouldn't necessarily have all of your networks advertised with BGP. And so BGP won't advertise that unless it's got knows how to find that. So it's in that router's routing table. Doesn't create any new routing information, it just advertises stuff that's already known. So basically an example here. So we're using 65,000 as an AS number. Any number above 65,000 and above is actually sort of like the private IP addressing ranges. They're free for you to use, basically. And so we're using 65,000 and 65,001. And so with that, we just have your neighbour command. So from company A, we actually talk to that address there. And of course, company, or ISP1, would talk to your internal address here, that's that router. And then, of course, then you need to have a network that you advertise. And so apparently that's the network we're advertising. Of course, this one is advertising all the zeros. The network address used in the network command does not have to be a directly connected network, but it does need to be known to the router, as I said. So how do we check that it's working? Show IP route. Sounds sensible to me. Show IP BGP and show IP BGP summary. And so that will give you the information. Okay, so we finished the chapter. So we've spoken about some of the technologies and how they work. We've spoken about PPPoE. We've also spoken about secure site-to-site VPNs. We've looked at GRE for tunneling, and we've looked at external BGP in a single-homed remote access network. Okay, there's the logo.